Example 3 is all about expanding. So sometimes you'll see it like this, in terms of log A, log B, or log C. Sometimes you'll see this same question where the instruction is expand completely. In A, we would say this is in terms of log A over B squared. If it's in terms of log A, the only thing allowed inside of the log is A. That's what in terms of log A means. So right now I have more than just A and more than just B inside the logarithm. So the goal is to take these, which are the left-hand side of your formulas, and just write them as the right-hand side of your formulas. And right now, we're just playing with formulas. And if someone says, why do we play with formulas? It's coming. Being really good at these formulas is going to allow us to solve complicated real-life problems. But first of all, you have to be good at the math and able to do the operations in order to solve a question where the operations are needed. So right now we're just practicing our log laws and seeing how they work. So if you're expanding completely, anything in your denominator is subtracted. Anything that's in your numerator is added. So the first step I can do is I can say, well, this log A is in my numerator. That's going to be positive minus log B squared because that's in my denominator. Dividing inside of a logarithm is the same as subtracting. And my bases stayed the same. Notice that no base is written, it's a base 10. Next, in terms of log B means there's no exponents. I can bring that exponent out in front. And this is my final answer, expanded completely. And the same shortcut that is used for combining as a single logarithm can be used when expanding completely. If you have more than one thing in your numerator, which we do, I have an A squared and I have a B to the 1/3, those can be added right away, and then we have the C in our denominator. That one can be subtracted, all in one step. So whatever is in your numerator, those ones are added. Whatever is in your denominator, those ones are subtracted. And then we can bring out the exponents out in front. So I'll add one more. With natural logarithms, we'll add a part C here. I'll add one with natural logarithms and some other exponent laws that you might have forgotten. So I'm going to have a natural log here. I'm going to put A cubed B to the 4, the 4th root of C times D squared. So first of all, whatever is added in our numerator, whatever is multiplied in our numerator, that will be added. And whatever is multiplied in our denominator, that will be subtracted. So we have 2 that will be negative and 2 that will be positive. Now, of these 4, this one's easy, this one's easy, that one's hard, and this one's easy. Right? The exponents you can just bring out in front. What can you do with the fourth root of c? And I'll write it off to the side. Do you remember how to change radicals to exponents? The fourth root of c is the same as c to what exponent? 1/4. So we need that fact to be able to bring that 1/4 out in front, and this would be expanded completely. Okay? If you forgot your radical rules to exponents, they come up a ton in calculus. So it's a good thing to review now. Anytime, like a square root is an exponent of a half, a cube root, an exponent of a third. If I had x cubed inside of a fifth root, wait for it, there it is. This is the same as x to the 3/5. So changing your radicals to exponents, something from grade 11 or maybe even grade 10, comes up a lot in calculus next year. So it's good to review that here as well. Okay, questions for this one? 14, 15, and 16.